Hello, everyone. Thank you for joining us this morning. We are just about to get started. Hello and welcome to the Marin Knotweed Action Team's 2023 Japanese Knotweed and a Summer Dry Watershed Symposium. On behalf of all the partners, welcome and thank you for joining us. My name is Lorenzo Levinger and I am the Knotweed Outreach Coordinator, CANR, University of California Cooperative Extension Office, the Marin Knotweed Action Team. Today we will examine and discuss Falopia japonica, Japanese knotweed, in our summer dry San Geronimo Valley here in Marin County, California. We are not certain when it first came to our valley, but it is native to the islands of Japan, coastal China, and the Korean Peninsula. An agent for the East India Company named Philip Franz von Seibold witnessed the plant in Japan during a visit in the 1820s, brought it home to the Netherlands where he had a nursery. By 1850, it had made its way to Kew Gardens in England. The showy red stems, large light green leaves, and pretty white flowers made it popular in gardens, soon spread beyond the garden wall. A member of the buckwheat family, it is an edible plant. It also has uses in traditional Chinese medicine, as well as being a source of nectar for honeybees. Unfortunately, it's disruptive to ecologies that it gets established in. Native plants and trees are outcompeted. Streams and riverbanks can be eroded, leading to turbidity in the water that is bad for water quality and fish. Our examination of this invasive weed will focus on its identification, survey and mapping, collaboration between diverse land managers, funding, treatment, and the future of eradicating this plant that is so disruptive to our environments. Today's program will feature a thorough discussion of our integrated pest management approach to Japanese knotweed. Cultural, mechanical, chemical, and biological control methods will be presented by our expert panelists. If you want continuing education units for this program, be sure to answer the poll questions after each speaker and stay for the exam after our panel discussion. Be sure to include your name and license number on the exam. If you have questions during the presentations, please put them in the Q&A and we will address them all at the end of the panel discussion. Our first speaker today was meant to be Bobby Simpson, who cannot make it. Bobby Simpson was a biologist with the National Park Service. For 17 years, she headed up the California Invasive Plant Program, working with 14 national parks on invasive issues. Based out of Point Reyes National Seashore, she joined with other land managers, problem solve, plan, and implement Japanese knotweed control within the Marin County Lagunitas Creek corridor. As a retiree, she continues to be fascinated and impressed with the caliber and tenacity of the joint effort to control knotweed. Stephen Swain, our environmental horticulture advisor, will be presenting her material along with some material of Anadirxes. So I would like to introduce Stephen Swain and thank you for stepping in at the last moment to help us out with this.
Right, that looks right. You guys hear me? Now we got it. That won't work. Yeah, that's not. Now I gotta figure out how to do it.
Go back to your video.
Got it. Now, can you guys hear me? David, can you hear me?
Yep.
Good. Okay. Excellent. Okay, so I'm going to do a quick introduction to Japanese knotweed. This is all from slides provided to me by Bobby Sims and Anadirxes. Dancing. Spacebar? No, forward, down, of course. Give me a second, I'm having some technical difficulties. Escape. Things seem to be working
You're in
well.
Zoom. So you can get on there. PowerPoint to escape or minimize your Zoom.
Oh, it's come on. Okay. My computer was too close. No, my arrow keys are not working. Oh, and show. I can't get out of Zoom. There we go. Got out of Zoom, I guess. So now maybe I can,
We can see you just fine.
I just go. There we go. Now does it work? Yay. Okay, thank you for bearing with me for a second. Okay, so we're going to be covering an introduction to Japanese knotweed. Again, slides by Bobby Simpson and Anna Dirksey. Here we go. So you may know Japanese knotweed by a variety of different names. We've got a number of different scientific ones up here. The common names, I think, are kind of instructive. They include names that relate to bamboo, Kontiki bamboo. They also include things that have the name of fleece flower, and they're describing things that characteristics that make this look like other plants, one way or another. So I'm going to be using the name Japanese knotweed and Philopia japonica for all the rest of the talk, and I imagine that's what everybody else is going to be doing too. The way we find this and identify it is it's got this lush green color, which is a lot like other plants. It's a little lighter green than a lot of the other things you're going to be seeing in a typical riparian watershed, at least around here on the West Coast. So that makes it stand out a little bit. Other things that make it stand out are the zigzag stems that are fairly characteristic. It's got these, what people like to call them, well, I'll get to that in a minute. Actually, it's got nodes like bamboo. That's really noticeable when the plant's young. As it gets big and covers up its stems, it's not so noticeable, but you'll still see it. So, and it's hollow like bamboo. It's also purple speckled. The stems are purple speckled like poison hemlock. And they're hollow like poison hemlock too. It's got shield-shaped leaves. I don't tend to think of them as shield-shaped. I tend to think of them as shovel-shaped. It's got that nice flat base where you could just, so it's sort of like it's suggesting to you, hey, kid, I see you got a shovel there. You feel lucky? Because that's pretty much where it is. It wants you to try and dig it up. It'll be really happy with that. So it spreads from rhizomes. You got a picture of the rhizome down in the lower right corner with the little shoots coming out and a cross section that shows it's hollow, and it can be bright orange when we first cut it. So that's some of the ways we use to figure out what it is. In the spring, it really looks very different from the mature plant. It has these little red stems that look much more bamboo-like when it first comes up. And as it matures, it puts out these flower stalks that are really kind of almost, well, fleecy looking. So it gets this name of the fleece flower. And then when in the winter, it dies back to the rhizomes, and all you're left with are the hollow stems. So, you know, this is where it starts looking a lot more bamboo, like when in the very beginning when it's growing and at the very end when it's dormant. So there are a number of other knotweeds out there, and all of them can be problematical. Japanese knotweed is at least probably the most problematical. It's a little smaller than some of the other knotweed species. And you'll notice that one of the other knotweeds is actually not in the genus Falopia, it's in the genus Persicaria. And these are smart weeds, and they're really widely, they're abundant. They're all over the place. So smart weeds and knotweeds are really closely related in the same family. And so it's no small wonder that they should look a little bit alike. So things that we can confuse it with, at least around here, we've got a California pipevine that looks an awful lot like it. It doesn't grow as tall, and it doesn't have anything nearly the similar juvenile form, but isn't a mature form. It looks like a prostrate version of Japanese knotweed, but it does have a heart-shaped leaf base, not a flat leaf base. Smartweed, we've already kind of covered. The leaves don't look that similar. Certainly other aspects of the plant are shared with Japanese knotweed. And then we've got elk clover, Aurelia, that also can fool you, and a number of other species that also look fairly similar. So why do we care? Well, Japanese knotweed is a bit of an ecosystem engineer. It's really kind of a cool plant as long as it's not in your backyard. It's an aggressive colonizer of moist habitats. It'll take almost any soil that you want to give it. It's got extensive rhizomes that run really deep, and those rhizomes fragment really easily. And all you need is 7 grams of rhizome to break off to be able to start a whole new colony. So 7 grams is about the size of a chunk of, a chunk of plant about the size of your fingernail. Rhizomes are particularly good at that. It can grow really quickly. 2 meters a month from March to August is at least been recorded. It's not always that fast, but that's pretty amazingly fast. And early emergence in great height shade out other vegetation and prevent regeneration, which causes all kinds of problems for other plants. It's a problem for the soil as well and the water. It increases erosion and turbidity. This is how the rhizomes fracture off and get washed downstream. And it can gradually eliminate native trees. So you can see in the little picture in the upper left there, it's formed pretty much a monoculture along stream banks. And that's a little bit of a problem because as it begins eliminating trees, it also eliminates the large woody debris that creatures need to be able to survive, and the loss of the nitrogen input from alders and other nitrogen fixing plants that live in the creek bed. So as a result of the loss of the trees, it causes creek temperatures to rise, and that's bad for a bunch of the things that depend on nice, cool creeks to survive. So this is a serious threat to endangered species. The endangered species recovery in the watershed, including native frogs, native salmon, and native shrimp. But it's not just a threat to native ecosystems, it's a threat to infrastructure as well. So Japanese knotweed is native to volcanic islands, so it is really good at growing up through, say, cooled lava beds and things like that. So it's not surprising to imagine that it's also really good at growing up through asphalt and concrete and brick walls and other infrastructure that we like to put near streams occasionally. And as such, we probably don't want to let it into our streams in the first place. So, or into our houses. So, where is the San Geronimo watershed? It's in Marin County, California, and what you're looking at in the map in the upper left is the salmon habitat, and in the lower right is where it actually is. The little pink dots are Japanese knotweed. And you can see it's spread all along the watershed. And we'll talk, this is spread over both public lands and private. And so the issue here for us was our timing. And you'll hear us talking about early detection, rapid response a number of times through this presentation. And the point is, the earlier you can find it after its introduction, the easier it is to eradicate. And at some point, once casual observation, it begins to show up, you're so far along the invasion curve that eradication becomes increasingly unlikely. Fortunately for us, we thought we detected it fairly early in this process because we had people out walking streams. And for anybody who doesn't yet have it, but is at risk, early detection by monitoring, actively looking for this is going to be really important to making it cost and time effective in order to eradicate it, if that's your goal. If you don't eradicate it, you will be pushed into management fairly quickly. Management is the point where you don't even pretend that you're going to ever eliminate it from the watershed, and you just try to keep the negative effects as minimal as possible. So it was probably introduced sometime around, actually our first detection, it was probably introduced decades before we found it. We're not quite sure exactly when. So decades is just, that's worth what you paid for it in this case. It was detected in 2011 and on public lands. And within a couple of years, they had been surveying and implementing treatments at the state and national parks properties. However, apparently repeated reintroductions of it from farther upstream suggested it was on private land. So in 2018, we formed the Marin Knotweed Action Team to try and work with local property owners to see if we could find it and move on. Other people are going to talk about that in more detail, so I just wanted to give you an idea of what the timeline looked like. We began treating on private parcels in about 2018. And that's about it for our introduction. Again, this was mostly put together by Bobby Simpson. I borrowed liberally from slides by Anna Dirksey, who you'll be hearing from later today. And thank you for your time. Stop my sharing. And that's what slides go.
Hi, everyone. Lorenzo here. Thank you very much, Stephen, for presenting that material on short notice. I'd like to thank Anna for contributing slides, and I'd like to thank Bobby Simpson. Her contribution to this project cannot be overstated. Right now, I'd like to invite you all to please complete a couple of our polls. And here's the first one. We'll get set up for our next presenter. That's Rachel. Rachel, we're ready for you to share your screen. If you are ready. The second poll.
All right. Well, hi, everybody. I'm Rachel Kiesel. And let's see how this works.
Yeah, Rachel, let me introduce you while we do this second poll. Thank you for being ready. Very much appreciated that. We'll take a minute to fill out this second poll, and I'll introduce you to Rachel. She's the conservation management specialist. Rachel is the conservation management specialist for the Golden Gate National Parks Conservancy. She leads early detection surveys for invasive plants, in addition to other vegetation related work. Her work on surveying and mapping, as well as collaboration between MCAT members, was invaluable to the success of our process. Thank you, Rachel, and take it away.
Great. Lorenzo, are you seeing the correct version of the slides? Just the slides themselves?
Yes,
Cool.
we are.
All right. Well, hi, everybody. Thanks for that intro. Let's see which one of these works. All right. So in addition to what Lorenzo just told you about me, I'd also say that I'm a plant enthusiast. I do a lot of work with data. In this work, I think my most important function is actually as a people manager, working with a a really tough crew that gets out in the field and does a hard job, and being a riparian surveyor, somebody who's willing to get into the weeds, as it were. So Stephen just gave us a great intro on the setting. In terms of the work that I'm looking at, we're talking about that Lagunitas Creek watershed with, there are 4 public agencies that actually have land within the watershed, and 2 of them have knotweed. So I want to point out a few things. This is that same watershed. Here is a dam that restricts Lagunitas Creek upstream, so there's no knotweed above that. So we're working down here in Samuel P. Taylor State Park and Point Reyes National Seashore, which is downstream even further. And those spots that you saw that were over on the private properties are more over here on San Geronimo Creek. So we're kind of starting downstream today, and then we'll, in the conversation, and we'll move upstream to talk about the work on the private properties. But the crew and I that I'll be talking about all work on these public properties for state parks and the National Park Service. So that's specifically Samuel P. Taylor State Park and Point Reyes National Seashore, which manages the section of the Golden Gate National Recreation Area there in Lagunitas Creek. So it's an interesting, it's technically part of the GGNRA, but it's managed by Point Reyes. And then I work for the Golden Gate National Parks Conservancy, which is the nonprofit support partner to this effort, and several others in Marin County. And we work with other partners, including Marin Water. That crew, that staff is highly involved in the creek because of the impacts of the dam and regulations that require them to monitor for the endangered steelhead or coho salmon and the threatened steelhead trout. So the fisheries staff actually notice knotweed on aquatic surveys. They also have staff who are engaged in winter habitat restoration to improve the work or improve the conditions in the creek for the salmon and the trout. And sometimes those staff leave us hints in the field. Sometimes they send us photos, or in past years, sometimes they have left more flagging. And then Marin County Parks has land in San Geronimo Valley, and so has maintained interest in the work of the Marin Knotweed Action Team and participates in all of this, although neither of those agencies really has knotweed populations on their public land. So all the work is happening on state and national parks. This is a photo that I got from one of those fisheries staff in 2021. It was it was dated February 11th from one of the fisheries staff who was out monitoring fish. Surprisingly, they were monitoring fish. And noticed that knotweed was emerging really early that year, or what they felt was early, and wanted to give us a tip off. We work in the creek in the summer, but it's nice to get an idea of what was going on when we weren't out there. This coordination includes other partners like the UC Cooperative Extension, the Marin Resource Conservation District, Marin County Ag, and others. And it's really this level of concerted emphasis on knotweed that gives the team that I work with the steam to get through a very rigorous survey. So I got a question for you here, not related to the quiz. Do you see the surveyor? We wear high vis, so I noticed them in this picture. And we wear high vis so that we can see each other at a distance in the vegetation matrix that we've got out there. So you've seen some other maps. This is a map that has some of the different public land designations. Those dots are knotweed locations on public land. The little finger of Samuel P. Taylor to the southeast, you can't see it under the map, but that is Samuel P. Taylor State Park. And this is a bit of what the public lands distribution has looked like over time. I'll say that we are still mapping zeros. We're going back and checking patches that haven't had plants in a year, 2, 3, or even 4. So some of those patches are now no plants. So in this watershed, and I suppose many others, what we're really dealing with in terms of dispersal are these high flow events. This is a photo, I believe, from Eric Ettlinger from Marin Water, showing a high flow event that's actually many years ago. When you're in the creek in the summer, it luckily doesn't look anything like this. And the creek channel can look much more narrow, but in some of the high flow events, we had a big high flow event, I think in 2020, I guess it was late 2019 or 2020. And you can get dispersal of those fragments that Stephen was talking about into new locations that maybe are coming from plants that didn't die in our treatments or from farther upstream on those private properties. So that's our goal, is to really survey the impacted floodplain each season, which is it's a challenging endeavor. The Samuel P. Taylor State Park reach of the creek is it's closer, it's more upstream and closer to any untreated private property. We get more public interaction. There's a campground, there are picnic areas, there's some bridges that overlook the creek and have some really pretty spots. So we see more humans. There's a lot of redwood Doug fir understory that makes it fairly open. As you can see in this photo, you might still have dense vegetation, but you can move through it fairly easily throughout a lot of this reach. We do get stretches of bedrock that I find particularly challenging to walk in, but it's a narrower floodplain. And in terms of the survey that we do, it's just easier. Once we get down to Point Reyes National Seashore, you could call it lush or brambly or brushy. We rarely see people. There aren't those public infrastructure points like campgrounds and picnic areas. We get into more willow, dogwood, blackberry, and other vegetation that is more cumbersome to move through. There are very deep stretches of the creek, and the floodplain in general widens out so that there's a much larger search area. And frankly, that section is just harder than Point Reyes. It happens right at the boundary for some reason. So in terms of our survey history, here's another timeline for you. My group started working on this in 2018, but as Stephen mentioned prior to that, the agencies had identified knotweed on public lands and had begun surveys and management, typically using contractor support. In 2018, the Parks Conservancy started surveys on Samuel P. Taylor State Park. We only did the survey, not the treatment. That reaches about 3.9 or 4 miles. And in 2019, we did both state parks, and we started doing the Point Reyes reach for a total survey length of 8 miles of floodplain, again, only doing the survey. We started to realize that we might have some expertise to bring, or some experience, some familiarity to bring on the treatment. So in 2020, we began doing both the survey and treatment, doing 8 miles that can feel like a million years. And in 2021 and 2022, we did the same thing. That we actually, I think between 2020 and a little bit in 2022, but 2020 and 2021, we actually did the 4 miles below the confluence with Nicasio Creek on Point Reyes National Seashore. Knotweed has not been detected down there. It's an even more difficult reach. But we wanted to give that a look. Bobby Simpson and Timothy Federal and likely others did a bit of a swim survey, I think in 2017 and 2018, to look at that reach. So it hadn't been looked at in a while. So we went down that as well. But our main, our bread and butter is that 8 miles of between inkwells or just below the Marin waterland, and then that confluence with Nicasio Creek. And as we look toward 2023, we're going to do a full survey again on Samuel P. Taylor, which is closer to any of that untreated private property. It's where the majority of new patches appear, if there are going to be new patches year on year. But we're going to take a modified approach for Point Reyes, because a couple of us are heading into our 6th round of these surveys, and they are quite difficult. So some of the benefits of using one crew is that we have very detailed memories of the sites, the access points to get back for treatment, and the repeated safety challenges that occur on certain stretches of the creek. We have a better understanding of the flagging and the interpretation of the data, and less coordination is required to execute the surveys and the treatment. So one of the things that we've run up on in these drought years is that the knotweed begins to dry out a little bit earlier, and we have to pull off the treatment. We're out there watching the plants, and we can shift from survey to treating any known patches, with a day or two of notice. So we can make sure that the timing of those treatments is as optimal as is feasible. The drawbacks of having one crew is that you have one very tired and somewhat beat up crew at the end of each survey season. This is not one of our staff members. Around 2018, we were finding large plants like these out in Lagunitas Creek. The plants were tall, they were vigorous. We were still finding large patches. We often had flowering plants, or at least 20 to 40% of the time we would get flowering plants. But once we get to 2022, down on the sort of bottom center, you have your knotweed here. You've got some flagging and tagging hanging overhead, but the plants are much smaller because we're detecting either new patches or patches that haven't fully succumbed to treatment yet. If you can pick out the little yellow flags, there are 4 of them in the bottom section of this photo. Those are flagging tiny knotweed plants at a site that just won't give up. We do have some sites that have not fully yielded to our efforts to kill them. And sometimes those look like this, where because of maybe, we get to some rhizomes that are kind of sticking up. We ended up pulling these out. It's not our preference. As Stephen said, we do not like to dig. But we did talk to the landowner in this case, and these tiny little sort of deformed leaves, there wasn't enough to actually get herbicide material onto the plants and have any sort of uptake. So in this case, we clipped those exposed rhizomes and took them with us. I'm pretty sure, since I don't know how to legally dispose of knotweed, they are still under my desk in a bag. Occasionally we do have to dig. So this flagging is hanging over the creek. We obviously can't do a herbicide treatment. We have some rules and regulations because of those threatened and endangered species. So in this case, we pull out something like a hori-hori and we dig it out. These are usually very small, shallowly rooted plants. So it's not that big of a deal. It comes up maybe once or twice a season, usually just once. And those we just have to take out by hand, but we do flag them so that we can hopefully find that spot again in the next season and check to make sure that that was effective. All of our flagging stays through to the next season unless something takes it away. The other thing I would mention is that we did have knotweed once show up in the creek in the crotch of a willow. It was actually in the air, suspended in what looked like a t-shirt that had accumulated some soil and some rhizome, and it was just growing out of just debris hanging over the creek. So in that case, we removed the whole t-shirt. So we have some challenges to finding these tiny plants now. Like I said, they're not big, they're not, we can time it for flowering season, but if none of the plants are old enough to produce flowers, that little white fleecy top that Stephen mentioned doesn't really show up. So what I'm going to do here is kind of take you through a day in the life of a crew of surveyors and give you an idea of what it's like down there doing the work. This is Samuel P. Taylor State Park, where we start and things are kind of open. Typically, we're going to have, our preference is to have a crew of 5, where we would have 2 people on each bank, so 4 surveyors and 1 doing the bank from the water, as Michael is doing here, rowing the vegetation to look for those tiny plants. We wear a lot of gear. You can see David here in that high-vis vest. We have, we've shifted from binoculars to monoculars because they're lighter and easier to carry. We have, he's got a Trimble GPS device in his hand. He's wearing some welly boots because he's not the person in the water that day. And full coverage, as thick of pants as you can stand to wear, long sleeves, and when you're not holding a device, leather gloves, and probably a walking stick. And the walking stick is about as much for beating vegetation as it is actually for walking, because a lot of times we're just trying to move things out of our way so we can move forward and look. So the sticks have a sort of a triple purpose of stability, beating vegetation out of the way, and rowing vegetation so you can look under things. You can see the density of vegetation here. It's not, I don't think, as lush as the populations that you get in wetter environments that do have that summer rain, but I'll say that it is tricky enough to find those plants in the matrix that we've got here. We start out kind of happy and ready to go. This is me and some blackberry, and I'm gonna go the way I'm pointing because that's where I'm at in the season. I'm ready. Let's go through this. We'll find something. If nothing, if we don't find knotweed, we find a way through, which is often what we're looking for down there. There's a lot of over and under and kind of figuring out what your best pathway is. And the goal here is to give as much coverage to the floodplain as you can. I didn't end up including a photo of our track logs, but we are collecting track logs to see what our coverage is like and to get an idea of how comprehensive we're able to be each season. The channel changes a lot, so it's not the same every season. We get into a lot of noxious vegetation. This is stinging nettle here, and the sort of complications out there have become so routine to the few of us who've done this many times that one of our staff, Michael here, who has since moved on, created a nice intro packet for any of the folks who join us on our surveys. So the crew that David Greenberger and I work with is a 4-person crew, and we invite people to join us for a day in the field so that we can get to that number 5 whenever possible. So we give them a bit of an intro, and mostly we want to prepare them, make sure that they are dressed correctly and ready for the things that they might encounter, like head-high stinging nettle and moving through blackberry. There are some other more exciting obstacles out there in the creek. This is a floating log jam. I had to sort of go back upstream when I found this spot, and I was coming from the left side of this photo under those willows, and I stepped out onto that log farthest to the left, and it was on the bank. It was completely stable. And I think I looked at that vegetation growing on the log next to it and assumed that it was stable. And when I stepped on it, it rolled, and I ended up riding the log, which was completely unanticipated. And this was down in Point Reyes. No one could see me. I just cracked up and tried to figure out a way to get off of it because it was actually very deep right there. Luckily, I was in waders and didn't get soaked. But finding your way through some of this and thoroughly checking it for knotweed is these are some of the challenges that we come up against as we try to be comprehensive and move toward that eradication goal. Sometimes the creek is just pretty and iconic. You get those brief moments where there's no spider web on your face and no plant is touching you, and you can just enjoy it. And sometimes you're going to have to climb. There's a lot of down material. Some of it's actually been placed to create benefits for the fish in that winter habitat. Large woody debris structures, we're finding that they create deep pools, which is part of their intention to create that cold water that Stephen talked about. But they are complicating our lives as knotweed surveyors. Always good to keep the goal in mind. The goal is a healthy creek for healthy fish. So we just have to figure it out and work around them. This is kind of what it looks like. You've got one person up on the bank, one person looking at the water or looking at the bank from the water, because the person up above couldn't easily see into those spots that the person in the water is able to cover. So in order to be efficient, we need as many people out there as we can, or it just goes very slowly. There are some funny things out there. One day we came upon a pair of goats who began to follow Michael. And this was, it ended up being pretty funny, but for a moment as he was walking us about his goat situation, I was concerned that they might be guard goats, but they were just loose goats and very curious to see if we had any food for them. Once they realized that I was keeping my carrots, they let us move along. The other thing for us to keep in mind out there, again, with that idea that the goal is a healthy creek and healthy wildlife, is that there are a lot of animals that use the creek. So we try to start our surveys at the very end of July as bird nesting season is wrapping up. And we could only do that if we move downstream. We're aware that a lot of riparian surveys start from the bottom and go upstream for things like stability as you walk in the creek. But because of that density of vegetation on the Point Reyes section, we're not able to effectively do that without disturbing birds. So we do start in that Samuel P. Taylor reach. And we see a lot of empty nests along our way. And this is another thing that we've put into that intro packet. We talk about this, we train on this, we look for signs of nesting birds, because again, we're out there, you know, I'm all about finding the knotweed, but we're trying to make sure that we're not causing damage as we proceed. So within a couple of days of starting, nesting season has ended. All the birds have gotten their postcard that they've got to leave. We continue our practice of being careful, sharing any observations of birds that may look like they're feeding young or flying in and out, or being particularly territorial. We share all that info over walkies and try to make sure that even if it's past that July 31st date, that we're taking care to protect the wildlife in the creek. This is not from Lagunitas Creek, and I think that's actually a white-tailed deer. But the other thing we run into down there, in addition to once scaring an otter out of a log jam, I got way too close to it, didn't know it was there. We also have some situations with deer, and it may not seem like a big deal because most of the time you see deer and they just move off. But this creek is abutted on one side by a busy road, Sir Francis Drake, and on the other side, typically by, in the section where we see these deer every year, right around Platform Bridge Road, on the other side by a popular trail. This year, we're trying to move as a line, right? So we can end up pushing deer, and we don't want to push them onto the road. We also don't want to run into the horns or the antlers of a buck who might feel threatened or cornered, which is very easy to sort of get into a situation where they're backed up against something like a willow thicket and nobody can move. We actually had a morning last year where we had 4 different deer. 2 were a mom and a baby, and then there were 2 bucks. So the mom and the baby were trying to move together. The 2 bucks were trying to move separately. And it was a very slow morning, dancing with deer, occasionally startling them and trying to make sure that we weren't going to inadvertently send them up to the road. So again, a lot of communication, being quiet in between that communication so you can hear what's going on, and anticipate when you're going to come, like crawl through a section of willow and come up on a buck who may not have heard you coming. That was a little bit more excitement that morning than I really wanted. There's some weird things out there on the creek. So if you work on creeks, people's stuff gets washed down. This was a rusty bucket of nails with a fern. What is actually usually more hazardous to us is lumber. So fences and decks that get ripped out in high flow events. So we have a rule that if you see lumber, you don't step on it. We had a staff member who stepped through some knee-high blackberry and pulled their leg up with a board attached to it. The nail had luckily gone through the most outer edge of his welly boot, did not hit his foot or even puncture the water tightness of the boot because of the way that the tread was made. But we're always trying to be careful for these sort of human hazards that have gone out. So we have some one uncovered well we're always looking for, a crazy debris flow that we have to cross that looks like this and actually has knotweed on it. So after getting stung by yellow jackets this year, I wore a beekeeper suit for the first time to do my my treatment of that site. They got me like 7 times, and you can't run because you'll break your femur. But we get to do fun stuff like that lower reach. We actually use kayaks. Here's the open stretch of that area, looking for knotweed from kayaks because it's too deep to walk and too brushy to bushwhack. So what does all that effort yield? We get a flag farm that helps us to find the plants again. It's really important for us to demarcate these plants. We use this yellow and orange and these Tyvek tags on the point raised stretch is where we use the Tyvek tags. We use those little pin flags if the plants are small, and we remove those after treatment. We get high quality GIS data of the surveys and the treatments using these GPS devices. And that data we store in ArcGIS Online and eventually deliver to the agencies. ArcGIS Online helps us just be able to all view the data as the survey is going along. It's a great tool for us. Oh, there's one slide that's out of order, so let me jump to that. We also get observations of other rare weeds like this Malfarata, which we do stop and take the time to treat while we're out there. It's one of our early detection species in the area. And with the treatments, we are seeing a lot of success. So in 2018 on state parks land, we had over 1,200 stems. We had a high flow event. I think in early 2019, some folks might remember that February high flow event, and the number of stems went up. Again, this is the reach that's closer to any untreated private property. And then we had a very successful treatment. We get down to 441 stems, 248, and we seem to be struggling to get those last few stems. Those plants are, again, much smaller. The gross area of knotweed is lower, but we continue to have 227 stems last year, and some of those smaller plants have more stems than a bigger plant would. You might get one healthy big stem, but instead you've got 4 or 5 little stems coming out of one of those distressed rhizomes. And oh, I think I have these numbers backwards, y'all. My apologies. Trust me when I say that the number of patches over 10 is actually 7 in 2022 and started at 42 in 2018. So the number of stems per patch is much smaller, and the total number of stems as well. And on the point raised section, my group doesn't have the data from 2018, but from 2019, when we started surveying there, we go from 354 down to 90 stems on the point raised section. So again, big decreases, but you see the change between 21 and 22 was only 17 stems, same reasons as state parks. And again, I inverted this, my apologies. We started with 11 patches over 10 in 2018, and we got down to 1 patch over 10 on the point raised section. For 2023, we're going to do that full survey of state parks, a mitigated type of survey where we focus on the areas of known knotweed in point raised. We're going to try to add a spring treatment to get over our hump with our treatment success. And we're considering cages and other ways to get to 0 as things like deer munch on our plants, and we have a herbivory issue. So we are troubleshooting and trying to find ways to bring this to a close or some sort of a maintenance level. If you want to know more, we do have a story map. That's a really funny link, but feel free to reach out to me and I can send it to you. It was made by some of our staff a few years ago. And with that, thank you very much.
Thank you, Rachel, for your report on Safari Adventure. We really appreciate the challenges that you overcome working in that environment, but also the sensitivity that you show to the environment. So thanks so much for that really entertaining and informative presentation. We've got the 3rd poll up right now, and we'll just get ready for our next presenter, who's Anna Dirksey. Need a minute or two to step away. We've got a couple of minutes. Pause right there. Our next presenter is Anna Dirksey. Anna is an inspector in the County of Marin Department of Agriculture, Weights and Measures. She has a master's degree from the University of Vermont in Natural Resources and Conservation, Environment, Society, and Public Affairs. Before starting at the County of Marin, Anna worked as a Japanese knotweed outreach coordinator for the EBC Cooperative Extension in Marin for 3 years. In addition to experience as a watershed educator, she also has extensive farm and land management experience, working on grass-based dairies, greeneries, and public lands. Her role working with diverse community members to coordinate a cohesive response to knotweed through outreach and education. It's key to community involvement and success. Anna, go ahead. Thank you.
Change my screen share 1 second. Make sure that the presentation is not overriding it. Please bear with me. Great. Here. There's. No. I'm getting Zoom quitting unexpected error message on my personal computer here.
You can still see your slide.
I don't know if people want to maybe take a bio break for 5 minutes.
Yeah, let's take a quick 5-minute break and make sure that we've got the good connection. Thanks for your patience, everyone.
Yeah, well,
Sometimes for me, Zoom opens us. We are a little ahead of schedule, so we've got time.
but I don't want all the pieces in mind.
That's great.
Yeah, it was good. You don't see. You guys are seeing that.
They're off
Oh,
this.
okay. Yeah, I'll let a few people return and I'll start talking in about 3 minutes, 11. Okay, so I hope everyone's back. If you guys stepped away for a second. Thank you, Lorenzo, for the introduction. Thank you, Rachel, again, for all your work on the private lands. I currently work for the County of Marin, but previously worked for UC Falls Extension. And my work has primarily been around the private land community members that live in San Geronimo on the upstream portion of San Geronimo Creek. So as others have touched upon, the Marin Knotweed Action Team is a larger collaboration between multiple partners. And I want to say how important that this, not necessarily organization, but this collaboration has been to enabling the, and giving the ability to treat those upstream, survey and treat upstream properties without this sort of underpinning and connections between these partners. The work that we do on the private land from the bank. And so some of those obviously include National Park Service, California State Parks, and Rachel touched upon Marin Water or Marin Municipal Water District, and then Marin County Parks and Open Space. And on the map on the left, you can see the red box shows the private landowner portion of the watershed along San Geronimo Creek and San Geronimo Valley. And we have a few challenges there that are different than Rachel's challenges with her public land surveys. Probably the number one challenge is it's only about 2 miles of actual stream length, but there's over 100 different property owners that are across that 2 mile in 3 separate towns. So San Geronimo, Forest Knolls, and Lagunitas. So, excuse me, as you can see, that is an issue in that all of a sudden, instead of connecting with 1 or 2 land agencies in terms of coordinating survey and treatment work, you're working with multiple different landowners across those properties. And so this is one example of a property that is in the San Geronimo Creek upstream portion. And one issue that we have with landowners that live along the creek is oftentimes they're not actually in the creek. And so the portion of creek there is a very developed, very channelized in portions. It also, in this particular picture, you don't see examples of this, but there's a lot of examples of riprap, concrete embankments, and there are often times where you may have a deck or the building structure that's almost at the top of the bank itself. So it's a little bit of a narrower portion of creek to survey versus the wide floodplains that the public land surveys take place upon. But at the same time, it's often also an environment that people are present, but not necessarily fully aware. So it's one of those things too, where because for a while, the Japanese knotweed, we've done a lot of work, obviously, and I'll talk more about the work that we've done in terms of the outreach, but it's not necessarily a common weed that people are aware of. So a lot of people, are aware of Himalayan blackberry, maybe vinca or English ivy as non-native invasive weeds that are problems in the watershed, but Japanese knotweed wasn't on a lot of people's radars prior to the beginning of the work that we started doing. For those of you who are familiar with Japanese knotweed, we have a pretty robust population right there on the left. But like I said, for a homeowner, maybe not a plant person, that's just more green vegetation in the creek setting. It's not necessarily something that they're going to be aware of in the same way that obviously myself or other people who are surveying and familiar with the plant are aware. One other thing I did want to briefly mention is because of the number of different sites and work that has to be done in terms of the coordination and outreach with individual landowners, the surveys I tended to survey, sort of earlier in the year to make sure that I'm able to complete all those surveys before treatment, and especially in the sense that usually we're treating in August, sometimes September, but with the most recent drought years, it has been August has been our treatment month. We're seeing plants that are in very different locations in terms of some might be in more sunny areas, shaded, obviously different soil types potentially. And so trying to capture that most ideal time to treat the plant is a little bit harder because we're not in the creek surveying and treating simultaneously in the same way they are on other lands. So I try to get the surveys done in May or June. And as far as nesting bird season, it's something that we are already in a very developed area where there's, oftentimes, while I'm surveying, I'll hear dogs barking and radio playing off the deck. So it's a slightly different environment than those public lands. So before treatment occurs, though, one thing that we had to do was get permission. And part of the work that I did back when I started in 2019 was around messaging to homeowners and things that, might be very important on an ecological or environmental level, may not be as important to homeowners, not necessarily, but obviously it's a different sort of messaging that occurs, and you're speaking to a broad population that some people might be very, very familiar with ecological concepts, while some people, might not have that familiarity. But these are some of the talking points that in my initial conversations with community members, I really wanted to focus on. Because I feel that they really resonated with a lot of people in those early talks. So as others have touched upon, the one really great thing about San Juan Creek is it has a endangered coho salmon population. And coho salmon are very dependent on temperature. And so one thing that we're really concerned about is Japanese knotweed preventing tree seedlings from establishing and regeneration. Japanese knotweed does have allelopathic properties similar to other plants such as black walnut, where they actually exude chemicals that prevent other plants in the surrounding root area from growing. As you can see in the background picture on this slide, Japanese knotweed can form very dense stands, and they do so, as Rachel mentioned, sometimes as early as January or February. So that early emergence, and when it's able to grow up to 6 feet tall, it ends up shading out other vegetation, including native vegetation, that is a food supply for those juvenile salmon in the spring. Despite having an extensive root rhizome and root structure, it doesn't do well at holding soil in place. And sedimentation in streams is always an issue, both obviously with reduced visibility for salmon and other riparian creatures to find food, and as well as the fact that it leads to extreme frank erosion. So for property owners, that could mean that the bank is eroding from underneath their property and their deck. And so, that aspect of Japanese knotweed's effects can sometimes, be something that resonates for them, as well as the other property damage potential that students highlighted, where Japanese knotweed have been known to destroy roads, grow up through cracks in foundations, and something that is especially pertinent in this area is it can destroy and damage septic systems. So San Geronimo Valley is not on sewer. Everybody does have their own septic system. So that in particular is something that's very important to landowners as septics are not very cheap to replace. So a lot of, the messaging that I also, share with homeowners has to do with the fact that, we are using an herbicide treatment. There are instances where manual removal may be the best or only option, but as you'll see in this slide, especially with large established stands, you can't manually remove all of that rhizome and root network without creating a massive crater in the side of a stream, which obviously is not desirable either. And have additional impacts to that stream setting. There have been instances where a single stem in a sandy area we've been able to remove, but as other areas across the United States, and I'll touch on that later as well, have shown herbicide treatments are the most effective, especially in the stream setting. And I believe Mark Heath will talk on this more, but we use an aquatically approved herbicide and a licensed vegetation management company, On Point Land Management, to do those treatments. But that allows, the herbicide treatment actually allows not only the top part of the plant there to be killed, but it actually allows that rhizome network to also be killed off, which is very important. So one thing that like Lorenzo mentioned, I went to school in Vermont, and so there it's a very, very different story in terms of how out of control Japanese knotweed has gotten in some reaches of streams in the state. So this is from Stowe, Vermont, these pictures. And this is actually 2021 photographs, but you can see it was taken in late September, and you can see the flowering Japanese knotweed that's literally as far as the eye can see on both sides of the banks there. And on the right, this is acres and acres of Japanese knotweed. And that's something that, I really have been, lucky perhaps to see that I've experienced what Japanese knotweed look like and do in other settings. I also want to, obviously preface that with the fact that Vermont is a very different setting than Mediterranean climate we're in. At the same time, we know certain things about Japanese knotweed, and the threat that it can pose is not a light. It's something that needs to be taken seriously. And even if this isn't necessarily what would happen if we were not to treat Japanese knotweed, it is the reality for how Japanese knotweed has taken over other stream settings. So I find that that's been, really helpful to communicate to landowners, to give them a sense of what's at stake, while also, understanding that, we do have much smaller populations here, and partly that is due to not potentially having it have been established as long in these settings. So in talking to private landowners, we do know that it's been here at least since the 80s, based on those recollections of what they've seen on their properties. And another thing that, I often touch on with landowners who say, well, there's benefits to Japanese knotweed, or I've heard it's a really great plant for these purposes. In its native setting, it's, not a threat. So it has other sorts of environmental factors that help keep it in check. So oftentimes it'll grow in volcanic soil, so it's not necessarily very rich when it's first deposited. We have biocontrols such as Apellara inodori psyllid that other speakers will be talking about later today. There's funguses such as the leaf spot fungus, and it just tends to grow differently. So it exhibits something in Japan called a central dieback tendency in that right bottom corner, where as the plant continues to grow, it actually starts to die back in the center, so other plants can move in and establish themselves. So I just want to take a minute to kind of talk about the funding aspect of how we've been able to work on the private lands. So this is something that we don't charge landowners for, either the survey work or the treatment work. And initially it was funded in conjunction with some grant money from National Park Service, UC Farm for Extension, and the County of Marin, when my position was first created. But for the last several years, beginning in 2018, we've also been able to access grant funding through the California Department of Food and Agricultural's Noxious Weed Grant Program. And that has been essential in allowing us to continue yearly surveys and treatments with that funding. You know, the land management agencies on public lands, they may have other sources of funding, or, you know, they may be doing other work for early detection of weeds. And so it's something they can kind of roll in to their budgets, but at the UC Cooperative Extension and County of Marin level, it's something where we need to have that additional funding. And one huge way that we've been able to do that is because Japanese knotweed has a pest rating of A. And so, as you can see on this slide, that means that basically it's a pest of known economic or environmental detriment, as we've kind of touched upon, and is either not known to be established in California, or is present in a limited distribution that allows for the possibility of eradication or successful containment. And most importantly, if found entering or established in the state, A-rated pests are subject to state or commissioner when acting as a state agent, enforced action involving eradication, quarantine regulation, containment, rejection, or other holding action. So that, you know, gives the County of Marin Department of Agriculture the authority to work on eradicating these plants. And it's gotten that A-rated pest rating where, because of a, basically you can be an A-rated, B-rated, C-rated, Q-rated pests or unknown pests, but it's basically kind of a equation that takes into account several different factors, including the ones that are highlighted on the screen. So for example, in the instance of Japanese knotweed, the climate host interaction risk is medium, because it is able to establish itself in moist habitats such as riparian areas, also, you know, urban settings, neglected gardens and that sort of thing. The known pest host range, the risk there is high, because it can basically, it doesn't need a host, it can grow wherever. As Rachel mentioned, you know, a dirty t-shirt and some soil is all Japanese knotweed really needs to grow. And as far as the pest dispersal potential in these riparian settings, the risk is very, very high because of the ability for it to be spread in those flood events. And obviously, in addition to flood events, humans, it's a beautiful plant, and I'll be the first one to tell you that, but it's a beautiful plant. And so, you know, as it was spread by humans originally too, that is another potential, and because it isn't poisonous, you know, it's not like poison oak or anything where it creates rashes, the skin, you know, people have given it to their neighbors and said, hey, look at this cool plant, let me plant it in my garden too. The economic impact was determined to be a medium risk, just because of the potential for fields and other agricultural impacts where Japanese knotweed could grow. And then obviously the environmental impact is high, just because it is such a notoriously invasive weed. And then the finals calculation then also takes into account how much is there in the state of California. So unlike Vermont and New England and some other places in the United States, such as the Pacific Northwest, we don't have that much knotweed, which is a great thing, as you can see on that map. So it's a low risk in terms of that. So that total score gives you that A rating. Like I said, that A rating gives the County Agricultural Commissioner's Office the authority then to regulate that plant and take eradication measures against it. And that ties into this slide in that part of the funding for applications for those noxious weed grants that we've been able to get over the last few years have required CEQA compliance, so the California Environmental Quality Act. So either environmental impact study, or in our case, because of that regulatory authority, we're able to qualify for CEQA exemption under either 15307 or 15308, which are those actions by regulatory agencies for protection of natural resources or protection of the environment. So like I said, the fact that we've been able to get funding is the only way that we've been able to, survey and treat, but also do the outreach. When you're talking about trying to contact, hundreds of people, you need a broad net. And so our efforts have included having a webpage presence through the University of California Cooperative Extension, a Facebook group, Facebook page, news articles in local newspapers such as the Marin IJ, radio ads on very hyper specific radio for West Marin, KWMR, as well as newspaper advertisements in the local, hyper local San Geronimo Valley Stone Soup newspaper. And then as far as direct outreach, community talks have been one way of doing it. Oftentimes, I found that it's hard to attract people to necessarily bring in a large group of people to just talk about plants. So sometimes having active audiences where people are going to be and asking permission to give a brief presentation on knotweed in those settings has been more helpful than trying to organize one-off events just about Japanese knotweed. And then in 2019, and luckily this was pre-COVID, so this was a possibility of doing a lot of door knocking, phone calls, and then we were able to, working with other partners, get a mailing list for everybody who was directly adjacent to the stream as a subset of the larger community, because those were the people that we originally reached out to as far as surveys. With only those landowners directly adjacent. This is just an example of our website, and it's still up if you ucanr.edu. If you want to go there, you can find it. These are some examples on this next slide here of door knockers that we left when we couldn't reach people, and then the advertisement that was posted in the Stone Soup. And at one point as well, there was an additional every door direct mailer that went out to everybody in San Geronimo. So not just those landowners adjacent to the creek, but we did want to, after the first year that I had been working and we had been able to do a lot more stream surveys in 2019 than originally in 2018 when work on public lands or private lands originally started. Kind of get the community, the broader community update. So this went out. San Geronimo has an extensive history of kind of being a funky place, and sort of capitalized on that with some of our marketing. Got a very rich musical history as well in terms of Janice Joplin and other greats that came or spent time there. So some of the challenges that we've been facing on the private lands in recent years, obviously, in addition to things like COVID, we've had a lot of turnover of homes. And so I also currently live in San Geronimo, so it's, I'm eyes and ears on the ground in my day-to-day life, in addition to my professional life. But there's been a lot of turnover of homeowners. And so, we've maybe already gotten permission from one homeowner to survey and treat or survey. And then that house goes up for sale, and you're then trying to figure out, okay, who's this new homeowner? And having to do a lot of those initial conversations around the outreach component. And similarly, there's a lot of locked gates, dogs, some deer, but like most of the things that I'm probably more afraid of surveying because some of these dogs that I'm not. May or may not be on friendly terms. And then, of course, the resistance to pesticide use, something that is something some people are comfortable with. Some people have a lot of questions. Some people, it's something that they're philosophically opposed to. And, trying to work with homeowners and educate, and also, kind of give the bigger picture of the fact that the upstream lands directly impact the work, the extensive work that Rachel's team is doing on the public lands. And, without tackling those upstream populations, we're not going to be able to successfully get rid of Japanese knotweed within the watershed, or, we're going to have to continue treating on those public lands for much longer because of that continued downstream movement. The other thing, obviously, with 50 different properties that we end up treating usually on an annual basis is it's a lot of coordination. So one thing I found helpful is to give options in terms of treatment times and windows, but and everybody's informed of the treatment, but we don't necessarily schedule one-on-one treatments. It's more of giving a broad range of, hey, we're going to be here in the morning, or, hey, we're gonna be here in the afternoon on this day. Like, if you have questions, like, please let me know, but we're not necessarily gonna show up and say, hey, we're gonna be there at 8:30 or 8:45 to treat your individual patch. Some of the vegetal challenges that we've been facing, as Rachel and others have highlighted, is the drought conditions these past few years have meant that oftentimes when we're going back to treat in August, sites that we've surveyed in May or June, the Japanese knotweed may already be dried up. And so trying to time that treatment window, especially where we're trying to maximize the number of properties that are treated in a short period of time, means that we're trying to have to pick the best time for the largest number of properties, and that might not be the most ideal time for certain populations. And in terms of just trying to catch new populations is always a challenge, and then as well having things like the deer, making sure that the or maybe rabbits, but I blame the deer personally. Making sure that there still is that above ground vegetation. And I included this picture just to kind of give an idea of sometimes how difficult it is to find new populations. So you'll see the pink flagging there on the left. And that, if you look on the right, is a Japanese knotweed stem. And the upstream portion of San Geronimo Creek is a little bit more exposed. As I said, it's a little bit less of the jungle that Rachel faces downstream. But at the same time, they're very, very tiny plants. And so obviously one important part is that we're coming back to sites year after year instead of doing a singular survey. Is that hopefully we don't miss plants, but in the event that we may do miss a plant because of their small size, we're still gonna be walking that stream over the next year as well. But I do want to share some of the successes as well, in addition to the challenges. And so here, this is data from the Marin County Open Data Portal that myself and others have collected. And 2018 was the first year of surveying and treatment on private land, but it was sort of the very beginning of the project, and so there's only about 12 sites that were treated that year. While the 2019 we had over 70 sites that we were able to treat. And you can see as we've progressed, we do have some sites that homeowners have declined to treat. There's some sites that, maybe just the timing, we found or learned about too late for treatment that year, but were treated the following year. You can see that green bar is what I want you to focus on. And so in the right on the key, it says monitoring, and those are all sites that that year we did not see any above ground vegetation. And so those are sites that we didn't need to treat, which is great because the less sites we have, the less herbicide we need to be using, which is our ultimate goal. And then you can see, by 2022 at this point, we're monitoring 43 sites, which is almost as many sites. There's 45 sites that were treated. So, we're getting closer and closer, and hopefully, this year, we'll be monitoring even more sites and having to treat more sites. Similar to Rachel, we've seen a noted decrease in stem counts as well. So we had close to 12,000 stems in 2019, and some of those were approximations, depending on the site. We weren't able to do individual stem counts for those sites that had hundreds of stems. We took, measurements of meters of a square meter and estimated based on that. In 2020, we had closer to 2,600 stems. By 2021, 1,200 stems. And in 2022, we did go back up in terms of our stem count, so 1,500 stems. But I want to show you this next picture to kind of tell you that maybe that the number of stems isn't always the best way of capturing our success. Because here's one site where you can see on the left there, Japanese knotweed, close to, 5 feet tall, if not taller. And that, those individual stems are a lot of vegetation. While this was in 2022, each flag is a stem. And so you can barely even see them. We're talking about stems now that are, maybe 3 inches or 6 inches off the ground. So our stem in 2019 is a very different stem than what we're talking about in terms of the vegetative biomass in 2022 or 2023. So, I think working within the community I live in, it's something where and just my nature in general, want to question, okay, are we doing the best that we can? Is this the kind of the right scope that we're working? And, I think it's important to have those conversations with community members. And so we might have time in the panel later to address some of these questions on the right there. Obviously, the most important one is how do we know if treatment is successful in terms of the fact that we know that Japanese knotweed has that extensive rhizome network. And so it's a matter of making sure that we've actually killed the rhizome and not, just sort of tricked it into not maybe appearing that year. But I just want to end too, and I know I'm almost at 30 minutes here. I think maybe a little over, but a quote from Eric Freifogel in his book, Our Oldest Task, Making Sense of Our Place in Nature. And this is something that, I really identify with this quote. For people to live well on land, they must instinctively, if not consciously, understand their roles as members of what Aldo Leopold termed the land community. They must see themselves as community members with responsibilities as such. For that to happen, for people to act responsibly in and toward nature, They must strive to understand the natural world. And they must be willing to act on their best understandings, even as they remain cognizant of the limits on what they know and can know, and thus of the virtue of acting humbly. In the end, stances must be taken, moral choices must be made, and decisions must arise based on best available evidence. And so I think, to me, I want to end on the fact that, there's a lot of unknowns in this work, and I think other land managers who might be on this webinar, dealing with landscape scale weed infestations, there's a lot of unknowns, and, at the same time, there are some knowns in terms of the detrimental impact that those weeds have on those landscapes and ecological systems. And so, working the best that we can as members of both the human community and the land community towards a journey. But thank you for your time, and I look forward to having any questions later in the panel.
Anna, thank you, thank you very much. And yeah, it would be nice if we have time during the panel discussion to talk about some of the intricacies of community outreach and that educational part of it, because language and approach is definitely important. Thank you very much. All right, now we have poll 4, so let's take a second to tackle that poll. All right, we'll give a few more seconds for anyone else that wants to complete this poll. Our next presenter is Mark Heath. Mark Heath is a pest control advisor and is the program's applicator. He's an expert on summer dry watershed invasive pest control. Mark, I can see that your first slide is up. That's great. Thank you. And go ahead and take it away whenever you're ready.
Thank you, Lorenzo. All right, good morning, everybody. I know I get the bonus time slot of right before lunch, but we'll make it through, have a good discussion, and talk about some interesting stuff. All right, oops. All right, so integrated pest management is something I just want to start with. We've talked a lot about a huge component of integrated pest management in the previous presentations by Rachel and Anna. A lot of that is just knowing your pest, knowing where it is, where it's located. And this project certainly spends a huge amount of time and effort in making that happen by looking in the whole watershed, finding the plants, identifying them along the reach, and having them ready to treat. So in the end, the treatment is actually pretty simple. And we'll get into that more in a second. But basically, integrated pest management, just for all of those that are not in this this industry, is a pretty broad concept at this point, and it's ever evolving. So the concept goes back to the 1960s and insect pest management specifically, and we really started to appreciate that natural predators had a huge role in insect pest management when we started using these really cheap and available new 1960s sort of pesticides that used to wipe out all the insects in totality. We realized that when all the natural predators went away, then those pest insects were even more difficult to control. and you were to sort of on this, this boom and bust cycle of using pesticides in perpetuity. So IPM really kind of reinforced that, there's a whole ecology out there, and that must be understood in pest management. And we had to do a better job than just using pesticides alone. So since then, that concept has really evolved into a much broader definition and many, many different definitions, depending on what type of organization and system you're actually talking about. So in this, is it structural control for termites, or is it a true agricultural system that's managing insect and pest plants, fungal pathogens, all those things in one actual agricultural agroecology system? Or is it, your kitchen counter and managing ants and cockroaches? There's different definitions that might apply to all those different situations because they're not really universal. So there's so many definitions now globally that Oregon State University actually has a database that they maintain of all the different definitions of IPM out there, and they are quite diverse. There's even a couple scientific papers that have come up in agriculture that just how broad this definition has become. So at best, IPM is really kind of, just so everybody knows, it's really structurally just a defined decision-making system in pest management. So now to get back to what we're going to talk about related to this particular project, we use the integrated pest management definition as defined by our land-grant college, University of California, cooperative extension program. And that is that IPM is an ecosystem-based strategy that focuses on long-term prevention of pests or the damage through a combination of techniques such as biological control, habitat manipulation, modification of cultural practices, and the use of resistant varieties. And specifically, pesticides are only used after monitoring indicates they are needed according to established guidelines, and treatments are made with the goal of removing only the target organism. So not broad scale elimination of the entire system. So talk about that really specifically, because my component of this presentation does really focus on pesticides, because that is largely how we're controlling Japanese knotweed. So pesticides are used only after monitoring indicates they are needed according to established guidelines, and treatments are made with the goal of removing only the target organism. So that's a critical component here in our discussion of IPM. So in an early detection, rapid response IPM scenario, prevention is really the #1 tool for pest elimination. So when we're talking about A-rated weeds, like Anna just described to us in the previous presentation, making sure that these pests do not come into the state over the borders, either through, roadside checks that CDFA maintains, the California, major highways and interstate freeways, or like inspections when we get shipped agricultural goods to the state. These are the best ways to eliminate these A-rated pests, because we know which ones are bad, and we don't want them in the state. Now, if prevention does fail, pesticides may be the best first choice and options for quickly and effectively eliminating a small pest population. And this ensures that the future pesticide applications are limited, and that greater environmental disturbances are limited. And this is true for pest plants, pest insects, pest fungi. But basically, sometimes I just wanted to reiterate that in an IPM program, pesticide can still be a first choice for a specific small nascent pest population, because the goal is to really just efficiently eliminate that pest with a known method, without doing a lot of experiments and a lot of trials, and ensure that that pest is removed from the system, and that we just really reduce the long-term use of pesticides for that particular pest plant or organism. So how it relates to A-rated weeds. So for most A-rated weeds here in California, they have very limited distributions. That's what helps give them that A rating. It's as Anna just described, it's great economic harm, but also they are population size that is manageable and that can be eliminated. So these are not things that are widely dispersed over the state, even though there's really bad weeds that have wide dispersals. We just can't eliminate them from the state, so we have to have other methods to manage them. So for many A-rated weeds, or pest organisms, even insects, herbicides are often the first choice for control. Mechanical and cultural controls are more beneficial for managing the large populations of established weeds that we have throughout the state. So things like, they might be eucalyptus or French broom or all kinds of things. We have many, many, many weeds in this state, and there's just no way of eliminating them in totality. And so they have you have to consider many more different options for how to manage those in their specific systems. So you don't harm the ecology and also just don't use a lot of herbicide. So going back to Japanese knotweed as our sort of the lens that we'll look through the A-rated weed situation here today is it's a perennial plant that is seasonally dormant. And we just, Rachel went over a lot of this earlier. Plants have really deep rooting structures. So 6 to 9 feet deep, this is not something that's easily hand removed at all. The underground roots and rhizomes are capable of storing lots of plant energy, and we're going to get to how that relates to an herbicide use. And they often really grow in difficult access locations. So herbicide strategies for knotweed specifically. So generally, we are working on Lagunitas Creek, and we're only using aquatically registered herbicides and adjuvants. So that's really important. Of all the pesticides that are, well, let's say all the herbicides that are regulated here in California, only a very small percentage of them can actually be used in non-crop situations. And so we have this great big list of herbicides here in California that is largely focused on agriculture and structural uses, and only a small percentage could be used in places like open spaces and parks and things like that. Now, within that group, there's even fewer that could be used in aquatic situations. So now we are down to a list of like a handful of regulated herbicides here in the state that we can use. So very, very limited choices, but also very good choices because those herbicides have demonstrated that they have really good toxicity characteristics that make them safe for the environment, safe for people, safe for around, even wildlife and pets and things like that. So that's really important. The other thing about the herbicides that we're going to use mostly for knotweed are they're phloem mobile. So that means that if they generally enter through the leaf, sometimes through the root, and we'll talk about that in a second, and they go through the phloem at a specific time of year, down into the roots, and they basically sort of work on and attack the storage tissues of that plant, especially for these perennials like Japanese knotweed that have a lot of storage tissue down in their roots. So that's really important. So again, there's we have a couple ways to get into the plant, mostly foliar, but soil is also a possibility. And then all these can be applied as an accurately directed spot spray. So that means they're like a water soluble herbicide that you can mix in a small container or backpack sprayer like this individual has here. And you can be very specific in your application. And all these products that we use here are at a caution level, which means that they're very safe to handle in even their most concentrated formulations right out of the jug. And they're safe around pets generally, property owners, things like that. So these are a really good class of products that work well for this project. So the number one thing we use is called a Mazapir. And that is the trade name here. That's little trademarks. It's usually Polaris or Habitat. Habitat is not as common now. Polaris is kind of a name brand generic that has replaced Habitat, but the original patented version was called Habitat. It's aquatically labeled. It's an ALS enzyme inhibiting herbicide, which is group 2. And that's actually a very large class of herbicides that we use here in California. So not only this particular brand or this particular molecule, Mazapir, but there's just a whole bunch of ALS enzyme inhibitors, and we'll talk about that in a sec. So this particular one works best on perennials when actively cycling carbohydrates to the roots. That's the phloem down to the roots that we learned in grade school. And that is usually keyed off the flowering and fruiting period. So for a perennial plant that is in a summer dry watershed that emerges in the spring, it gets to peak height in the late summer. And then at that point, it's got a massive amount of carbohydrates stored that it starts cycling down into its roots right before it goes dormant again. And so that is a critical time period for using a flow mobile herbicide, because we want to basically key off that period and get our herbicide into the plant at that moment, so the herbicide goes down into those storage tissues. And then this particular one can be taken up through the foliage and or roots, so it does have some soil activity. That's not as advantageous in an aquatic situation, but there are, most of our situations are riparian, so they're actually, kind of a hybrid between terrestrial and aquatic areas. And anything that does go into the soil can be taken up by the roots in that way as well. And the one issue with this is it can be very slow acting. It's just depending on the plant, it cycles pretty quickly in Japanese knotweed, but some plants like English ivy and some of the woody plants, it can take up to like a year, 18 months to actually get lethality from a product like this. And just to jump back a little bit, the ALS enzyme inhibiting herbicides, they basically act on a specific set of enzymes that relate to the metabolism of three specific amino acids in the plant. And when that is blocked, the plant basically starves to death. And that's why we're really wanting to get this down into the storage tissues, because a plant can override this if it has enough of those amino acids in such large stored capacities that the amount of herbicide in the plant doesn't necessarily counteract what it can accommodate through its reserve of those amino acids. So there is a sort of a dose dependency of all these different herbicides we're going to talk about. So glyphosate is the second one, and that is most very commonly known globally as the trade name Roundup or Rodeo. So there's two aquatic formulations that we tend to use, and they're either Rodeo or Roundup Custom, which is pretty much the same thing. It's very, very similar label, but this is a version of glyphosate that's pretty much pure glyphosate dissolved in water with no additional additives. And then we have to add an additional surfactant to make it work. And we'll talk about that in a second. So this is an aquatically labeled EPSP enzyme inhibiting herbicide. And unlike ALS herbicides, this actually acts on 3 other amino acids that are separate from what the ALS type of herbicide does. And there's only a single herbicide that does this specific mode of action, and that is glyphosate. So glyphosate is very unique. No other herbicides out there in the world do what this does. And so the combination of these two would then theoretically bind and prohibit 6 different amino acids from being metabolized in the plant. So this also works best on perennials when actively cycling carbohydrates down to the roots and through the phloem. And again, so the timing is very similar, but not necessarily exactly the same. So Roundup can sometimes work a little bit better, a little bit earlier when the plant is a little bit more actively growing. And so, all these plants vary a little bit in terms of the exact, perfect period for dosing. This can be taken up by the leaves only. So Roundup is also very unique in that it's pretty much whatever hits and dries up on the plant is what you get. And so it's very, very specific to that moment in time. And so that's really good for selectivity for us, because we know that anything that might hit the soil or the water or anything else will be completely inactive and will not have any capacity to do anything after that initial spray event. So this is probably one of the most specific and targeted herbicides that you could actually use here in California, and that's why it's very good for us, because it has a great selectivity when we're working around really things that you don't want to impact, because there's just zero soil activity, and then whatever hits the leaf goes into the plant, and after that, that's it. There's nothing else that can happen. Another benefit of this particular herbicide is it is relatively quick acting, a little bit quicker than imazapyr, and so it's not as key in the way that we do herbicide applications here in Lagunitas Creek, but under some circumstances, you might actually combine these herbicides just because you want to see if you actually hit the plant and get some color change. And with imazapyr, like I said, it could be 6 to 9 months before you get any sort of indication that the plant was actually treated. But glyphosate gives you a color change pretty rapidly after application. So it's sometimes just helpful to know in complex spray environments, like what you hit, what you missed. but that's a little less critical for us because we usually get 1 or 2 days to do this. So, as we said, these aquatic approved herbicides often lack surfactants, and then you have to add your own aquatic approved surfactant. And this is critical because the herbicides will not work generally without a surfactant, especially for anything that's applied to the leaves and the foliage. To enter the foliage, you have to have a surfactant. It's true that imazapyr might be able, without a surfactant, to if it was in the soil, the plant could still likely take it up pretty easily, no problem. But this surfactant would be really critical to get the max dose of both these products into the plant where they belong on the leaf. And that's what we really want. So this is just an aquatically labeled ethylated vegetable seed oil. More commonly, they're methylated vegetable seed oils, but they're it's just a a slightly different process with this particular one that we use. It's got a very good toxicity profile for aquatics and humans. It doesn't even have a signal word, so it's not caution level. It's just it doesn't even have one. So it's pretty much a vegetable oil with some emulsifiers in it that allow it to do what it does. And what this really does is it enhances herbicide uptake through the leaves. And so it does a couple different things. It because it's an oil, it helps dissolve that waxy leaf cuticle. And when we talk about the timing of this application, we're even in West Marin County, it's it can get warm in the summertime in August when we do this application, and the humidity is relatively low, and the plants generally have probably their maximum water saving kind of drought resistant measures up, which includes a really thick waxy leaf cuticle. So it's really important that at that time of the year we need to dissolve that to the extent possible to get that herbicide into the plant. It also, because it's an oil, it helps extend the dry time a little bit. So that helps both of these herbicides stay liquid a little longer so they can continue to get into the plant over a longer period of time, which just basically gets more herbicide into the plant. If the herbicide dries too quickly on the leaf, especially in the case of glyphosate, only a small percentage of that drop of herbicide might actually get into the plant, and then the rest will dry on the leaf surface, crystallize, and blow off into the environment and do nothing. So we really want to get as much herbicide into the plant as possible and not the environment. And so that also includes just having a nice long dry time. And then it also takes a drop of herbicide and spreads it over a very large surface area, which is the point of most surfactants, just to help wet that surface as much as we can. So again, these surfactants, there's a lot of different surfactants, but we think we've got a pretty good one that does a pretty good job, and it is really an essential component of the overall mixture to make it work. So success of Japanese knotweed management really depends on a couple critical factors here. So for herbicides to work, they must be both absorbed into the plant and then translocated into the specific regions of the plant where the herbicides have activity. So in this particular case, we know that both are different types of enzyme inhibitors that relate to specific amino acids that create key proteins in the plant to survive. And so we really want to get down to the storage tissues and where all those amino acids might be stored. So both these processes are influenced by the availability of the products at the sites of absorption, so on the root and leaf, the environmental factors such as temperature, light, relative humidity, and soil moisture, and the plant's phenology and life stage. So there's a lot of things we got to have all lined up for these herbicides to work the best they can. And like I mentioned just a second ago, environmental factors is one of the more challenging things we have. In some periods of the year, we have to deal with rain and fog, and we can't spray then. And then we have in the later periods, it gets too dry and the plants get drought stressed. And if they get too much light and low humidities and the soil moisture drops, then they actually go semi-dormant and they don't really process and metabolize these herbicides very well. So it's those environmental factors are very hard to juggle for us because they're ever changing, and it's very it's very difficult to put that in a calendar and get that perfect. Second big thing is the plant's phenology. This plant does go completely dormant at some stage in its life. And so if we're, too late, then you miss it. So for these ALS and EPSP enzyme inhibiting herbicides, the herbicide dose is also important, as the specific amount of herbicide must be present in the plant to inhibit the enzymes within the plant and amino acids in those storage tissues. So that's a lot to kind of manage for 1 or 2 days of application. So knotweed is most susceptible to the flow of mobile herbicides just before dormancy during pretty much what they consider max height and maybe between the max height and the flowering period. So we want as much leaf area as possible to get the maximum foliar dose of herbicide into the plant. And if we're too early, the herbicide won't translocate or there won't be enough leaf area. And if we're too late, it's going dormant and it also won't locate. So there's kind of a narrow window of opportunity that we get. And this period may also generally coincide with California's, recent long-term drought where these plants do get stressed even though they're growing really close to a creek. The water in the creek gets low. The plants may or may not be right in the actual channel and they get stressed. So that will impair our treatment a little bit. So the other thing is that over the long term, and this was mentioned by both, I think, Anna and Rachel, is that these plants have been treated multiple times and that at some point there's just not enough leaf area to get a sufficient dose into the plant in some of these later stages of application. So we have to watch that. So we talk about 2 herbicides, and what we often do is we combine them because multiple herbicides provide a hedge against these non-ideal conditions. So it's not like we need a super dose of pesticide to get into the plant to maximally work on it, but it's more critical that we have a real challenging set of environmental and sort of phenology conditions that we have to meet, and that we want 2 active ingredients that are both slightly different to sort of hedge against that 1 or 2 day window that we actually get to do the treatment, because we really get one shot at this for this particular project, and that's it. Anna already described how difficult it was to line up all these different private landowners for treatments, and that's an enormous feat. And so literally we have 1 or 2 days a year to get this right, and all the environmental conditions may or may not line up for us on our behalf. So that's really why we're using a multiple set of herbicides to do this treatment. So I think we got 25 minutes down here. So I just want to reiterate that with a few parting thoughts here on just A-rated weeds. So I'm someone that actually works as an applicator and a pest control advisor with a number of different county agricultural commissioners' office here in Northern California on A-rated weeds. And none of these A-rated weeds are what I would call super weeds. They're not immune to herbicide treatments. They're not immune to hand pulling some of them. They're actually, just regular old plants doing their thing. But what they all seem to share is a common characteristic where they evade our human systems for management. And by what I mean there is, they often cross jurisdictional boundaries. I think knotweed is a very great classic case of all those little tiny populations of plants being spread out over individual private property parcels that all have to line up at one period of the year to treat. And that's just extraordinarily difficult. I work on other projects that the weeds generally like disturbed areas along rights of way. So we might have county roads, we might have Caltrans, we might have railways and BART and pipelines, all basically supporting one small population. But to do the treatment, you have to get consent from all those different institutions and all their different, they might have different herbicide and IPM guidelines for all their different little parcels. And you might take one patch of plants that are on 5 or 6 different jurisdictional boundaries. So that gets really, really difficult to treat. And it's not because the plant is immune from herbicide or treatment. It's because it's immune from our human systems. It's evolved over 10,000 years to evade Microsoft Outlook, because that's how we operate. We generally deal with plants 5 days a week, and we don't do a lot during holiday periods. So if you're a plant that likes to grow between Thanksgiving and Christmas, you might have a really good opportunity to survive in this world. Other plants I deal with, rush skeleton weed is a great example. It loves to grow and flower right at the end of California's fiscal year, between the end of June and the beginning of July. And that's a period of time that we generally don't get to treat weeds, because the entire state shuts down and there's no contracts allowed at that period of time. So the weed does really well. So these plants grow on their own solar calendar. They just persist, based on the amount of moisture in the soil, the sunshine they get on a given day. And then we are hampered by our own issues, and that's really what it comes down to. Some of these A-rated weeds are really, really difficult. And I just like to say that the Japanese knotweed program has been really great, in that the group of people that wanted to treat this plant organized into MCAT. So, and they have a coordinator, they have funding, and all year round they participate just so they can treat plants a few days of the year, because the treatment itself is relatively simple. But the organization and to deal with all the different institutions that have to give permission for the treatment is an outstanding amount of effort. And that's largely how these A-rated weeds survive. So that's all I wanted to say on that. And I think that's about my time.
Thank you very much, Mark, for both your level of detail and also some of the broader problems, questions, and solutions that you mentioned. We have another brief poll on Mark's work, poll 5, we just brought up. We'll take about 2 minutes for people to do that. Then we have our final presenter. We'll take another small break after that for the panel discussion and exam after for people that it's used. Right, we'll give everyone just a couple more seconds if they want to participate in this poll, which I encourage everyone to please, for our data metrics. Next, we're very fortunate to have Chris Orkin. He works for the California Department of Food and Agriculture with biological controls for Japanese knotweed. Very exciting. Some of these possibilities promising for the future. So if you are there, Chris.
I am here.
Great. Let's stop sharing that. Thank you. There we go.
I think I got it going here.
I see your slide.
I'm here and available. Excellent. Yes. Well, thanks, Lorenzo. And
Whenever you're ready, go ahead.
perfect. Thank you so much for inviting me to be a part of this. It's been really great to see all the work that everybody's been doing on eradication and control of this nasty little weed, or nasty, incredibly large weed. So I'm going to be talking about the role that the CDFA biological control program is taking in trying to help with the control of knotweed in California. So just to give you a brief overview of the program itself and what we are and what we do. So the program itself has been around for since the 70s, really, but in 2012 was closed due to budget shortfalls from the recession. But luckily we had two diehard scientists here who, though they were officially working in other jobs, managed to keep biocontrol alive under the radar in CDFA, so to speak, or as not as an official program, using extramural funding. And this was Charlie Pickett on the left here and Mike Pitcairn on the right. Some of you, if you've been working with weeds in the state for a while, may recognize Mike Pitcairn, as he was sort of the primary weed biocontrol guy for many, many years. So they kept the program going, and then in late 2017, the program was refunded and restarted, and including the two scientists, Charlie and Mike, there was right away one environmental scientist hired as well, who had been with the program before, Viola Popescu, seen here on the right. And then I was hired in mid-2018 to join the program as an environmental scientist as well. And then we hired Dr. Ricky Lara, seen in the middle here, who is a senior environmental scientist specialist with a PhD in biological control. And we hired in 2021 another environmental scientist, Vincent McVeigh, here. And we're just in the process of hiring our fifth or another permanent staff member. Unfortunately, well, I mean, they did their work, but Charlie and Mike have both retired with full honors. So the program now stands at, well, oh, sorry, we also have a number of seasonal employees that we call them seasonal, but they actually work year-round part-time, our agricultural technicians. So and they're vital to our work for sure as well. So we currently have 5 permanent positions with 4 seasonals. We're hoping to continue growing the program and hiring hopefully 1 to 2 more permanent staff in the coming 2 years. But we are still continuing to secure funding, both extramural and general fund, hopefully funding over the coming years. So we're not yet at the stage where we can resubscribe to our Opulent Living magazine. So what we do as a program is biological control. So what is biological control? Just to refresh people's memories, this was defined, the definition that we use most commonly now was defined by Paul Devac in 1964, where it is the action of parasites, predators, or pathogens in maintaining another organism's population density at a lower average than would occur in their absence. So basically what we're talking about is an ecological process where things are interacting to maintain reasonable numbers of populations so nothing explodes. So there are 3 major categories of biological control. There's classical biological control, which is the control of a pest or weed species through the introduction and establishment of co-evolved natural enemies. So usually from the region where the pest or weed originally comes from. There's augmentative biological control, which is when you release additional individuals of a control agent to increase the population of those natural enemies, but they usually aren't able to persist in the environment. So they need to be continuously added to the environment every season. And then there's conservation biological control, which is where actions are taken to protect and maintain populations of the native natural enemies that are already in a system. So using what's already there to try and control things. And these latter two really aren't used so much with weeds, but are more of something used for insect control and pest control. So we focus in the biological control program specifically on classical biological control. And so what that looks like is so when you have your invasion curve and it maxes out and the plant is established, you have then some sort of weed density that is maintained at a, at that high level. And what you do is you find these control agents, and that is a process in itself. Introduce the agent. If the agent is able to establish, it attacks the plant and brings down the density of those weeds down to a manageable level. And so that's what you see here going on the green line. The biocontrol agent is introduced, attacks the plant, brings down the population densities, allowing desirable vegetation then to reinvade and hopefully take back over at least a portion of the habitat, and you may manage to maintain that weed below a damage threshold or an economically important level. So that's the ideal case. What one must realize is that you have to manage your expectations, because you need several things to be present or to occur for biological control to work properly. So first off, you actually have to have a large enough population of the target weed for the agent to establish on. If you have too few, if you just have a couple plants, there's not going to be enough there for them to grow on and to maintain populations year after year. The other thing is that it takes an enormous amount of time usually for biocontrol impacts to show themselves. So this is often on the order of with weeds, particularly 10 to 20 years sometimes before you really say, oh, it's gone, not gone, but it's greatly reduced. And the success of this can be very variable. So the other thing to realize is that this is not eradication. Biological control does not eradicate the targets that it's affecting. What it does is suppresses those weeds or pests below a damage threshold. So bringing them down below a level where they're going to have an economic or a major ecological impact. And then the other thing is that it takes again, there's more time in terms of assessing the success of the biocontrol agent. So you have to monitor before you put the agent out, get good population estimates there, monitor during to see if you're getting establishment. If it's having an effect, then you look at it for many years after and continue following up every several years to see that it's still working. So it is a very involved process. So what do we do specifically with the CDFA biological control program? We work on both weeds and pests, principally in agricultural systems, but also in rangeland and forests. Most of our weed work is actually in rangeland and forests and natural habitats. And so what we do is we release and monitor co-evolved natural enemies to help protect these crops and rangelands. We also do a lot of research, both ourselves and collaboratively with other agencies, into new potential agents for emerging weeds and pests. And our work is really post-eradication. So once something is established here and it's become evident that the methods that are being used currently are not going to control it any longer, that's typically when biological control moves in. We do in some cases work more proactively as well, but by and large, we're working after something has established in the state. So the purpose of doing biological control and the stated reason for having a state biological control program is really to provide long-term economical control solutions to weeds and pests that are in the state. So we work on a number of different weeds right now in terms of evaluating and releasing agents. So we are working on agents for yellow star thistle, Russian knotweed, common crupina, puncture vine, water hyacinth, arundo reed, Canada thistle, hoary cress, and of course today's star, the Japanese and giant knotweeds. So biological control of Japanese and giant knotweeds is really just kind of getting going in North America, in terms of the actual releasing agents here, but it's been going on, the process has been going on for many, many years. And so the first step in trying to get potential biocontrol agents, of course, is to go and try and find them. And so starting in the early 2000s, numbers of trips were made to Japan looking for insects and diseases, rusts, this kind of thing, that were attacking knotweeds in Japan. And so over the course of those trips, they found about 180 natural enemy species that were attacking knotweeds. They then evaluated those, and a lot of this work was done out of Oregon State University. They winnowed that down to 4 principal candidates, all insects, that they then did host testing on. And so in order to release a agent onto a weed or a pest, you need to show that it will not destroy the ecology of the environment that is already there, of the native environment. And so there's a lot of testing that goes on, testing both plant species and insect species to see how they might be affected by potential agents or potential candidates for control. And so they tested these 4 candidates on 70 plant species that were related to knotweeds or occupied the same sort of ecological habitats as knotweeds. And in doing all of that, they found just one of those 180 to be sufficiently host specific so that it would not attack any other plants in the area. And this was the knotweed psyllid Aphilera itadori. And so this was finally permitted for release in 2020. So when they were doing the evaluation, the insect itself is a sap feeding insect. And so they're related to the Asian citrus psyllid and these sorts of things. These guys are good for us. And so what you see here is on the left is an adult that has laid a bunch of eggs along the stem, sort of at the node. They like to lay the eggs at the nodes of the knotweeds. The immatures then hatch out and start feeding on the plant saps. And they exude, you can see sort of these little fuzzy strings sticking out of the immatures in the middle image here. And that's the developing lerp, which is basically a mixture of sugar and wax that is used to sort of sometimes to protect when they're in large numbers, it protects the immatures potentially from parasitoids and that sort and predation potentially, because it's a sort of a sticky wax. And then on the right, you see the adult psyllid. And so when you see these in numbers, when there's higher populations, you start to see this lerp, the wax and sugar build up in locations where there's large numbers of particularly the immatures, and you get this kind of sign showing up on the plants and leaves. And so it's something to look for in the field, and you see it when you're growing them in the greenhouse for sure. But all this feeding activity then has impacts on the plants. And so the psyllids tend to lay their eggs on the developing stems, and so the youngest tissue, and the immatures then start feeding immediately, which causes leaf curl. So you see this, the stem on the developing stem on the left, and the beginnings of the leaf curl below it. And over time, and with sufficient numbers, you get massive amounts of deformity of the developing tissues. And eventually, this is in the greenhouse, you get death because there's so much extraction of resources from the plant, and it just can't keep up with the damage and can't process, can't photosynthesize properly. So this is ideally what we would like to see in the field. So in terms of selecting the appropriate agents, now once they found the actual species, it was determined that actually they needed to go even further, and because Japan is so large and the psyllid is found across the country, they needed to do a little more work to determine which populations they should sample from to use in North America. And so this involved doing some climate modeling. And what they found is that there was a northern population in Hokkaido that where the climate matched best sort of those mid-latitudes of North America, and then a southern, the Kyushu, on Kyushu Island, a southern population that did better for sort of the western coast and southern US locations in terms of matching with climate. And so they selected those two populations to that's what they did further testing on, and that's what they were able to work with. The interesting thing in Japan is that there's actually a difference as you move from north to south in terms of which knotweed is most prevalent. And so in the north, it was mostly giant knotweed that was the prevalent knotweed. And then as you move south, you get mostly Japanese knotweed. And so this was something that came into or became an issue going forward in terms of determining which of these biotypes to use. And so what they found in doing the research was that the Hokkaido psyllid from the north had a bigger impact, not surprisingly, given the distribution of the plants, on giant knotweed, but also on the hybrid giant and Japanese knotweed, and basically did better overall on giant knotweed, and was a better climate match for northern parts of North America, of the range of knotweeds in North America. The Kyushu psyllid had a bigger impact on Japanese knotweed, did better in terms of reproduction, but also did better reproductively on the hybrid than the Hokkaido psyllid. So definitely some differences between the populations here, but it had a better climate match for the southern and coastal areas of North America. So it was permitted for release in 2020. In California, we received the first knotweed psyllids for release in 2021. These were all of the Kyushu strain, so that southern strain. And we made releases at 2 sites in Humboldt County. And so the releases at that time were done. We received 2,000 individuals to release. We did one release in a large patch of Japanese knotweed, about 1,500, because this strain was thought to be better on Japanese knotweed. And so what you see here is our county collaborator, David Giuliano, who works with Humboldt County, helping us put together basically a mesh sleeve over top of a developing branch. We then emptied the vial of 1,500 psyllids into there, tied it off, and left it for a week. And this is to help them sort of establish and hopefully lay some eggs. And then we removed the sleeve and then went back to check on them later. We did used the same method in a stand of giant knotweed, doing the same thing. Went back 6 weeks later, which is supposed to be about the time it takes for the life cycle to complete from egg to adult. And unfortunately, we saw no establishment in 2021. So we found one adult by sweeping, but in terms of doing our standardized surveys of both the Japanese knotweed stand and the giant knotweed stand, we found no evidence of eggs or that. So in 2022, we made more releases, but this time we had both the Kyushu strain for the Japanese knotweed and the Hokkaido strain for the giant knotweed. And so we released those at the same 2 sites in Humboldt County, appropriately based on the biotype. But we used a slightly different release procedure. What we did is that actually at the end of 2021, when we found no establishment, we grabbed cuttings and roots of the from those two stands, the Japanese knotweed and the giant knotweed stands, brought them into our greenhouses and grew up plants in our greenhouses. We then put these into cages seen here and introduced the appropriate biotype onto them and grew up our own colonies of Kyushu and Hokkaido biotypes. We then took these plants and replanted them back into their stands, but they being completely infested. And so you see here the transport in cages up to Humboldt County from Sacramento, and we basically did finally did some real work and did some digging and some pickaxing and all that good stuff to get and macheteing into the middle of these stands and planted these plants there with mark them out with you see the orange flagging tape here. So these were plants that then had all life stages of the psyllid on them and were able to grow. We watered them in and left them to grow there, and hopefully having multiple life stages would increase the chance that they would establish. And so we did this twice in 2022. Unfortunately, there's still no evidence of establishment. So, and this unfortunately is something that has been seen with other states that have been doing releases as well. Part of this is a lot of these stands are really, really big. And so, when you're dumping 1,000 tiny little insects into a giant stand of plants, they will disperse through it, and you'll be lucky to find them often. But that said, it often also takes many releases and years for establishment to occur. And so that may be just what we're seeing here. I mean, even starlings took, I think, 11 times before they finally established here. So, it does take many years to do this. The other nice thing on the horizon, though, is that there is currently another biotype that has been evaluated, that has been put up for permitted releasing, and that is the Murakami biotype. And so this is found kind of in between the two previous biotypes, and it does something also a little bit different in that when it is growing on the plant, I mean, they all cause the leaves to curl up, but these actually curl around the immatures tend to be inside the leaves more and not nearly as exposed. And so it's almost like they're forming a gall out of the leaf. And so they receive more protection. And so it's a slightly different behavior. So the permit application for release is currently, for this biotype, is currently open for public comment. And so that the public comment ends March 13th. And so if anybody here who's passionate about the possibility of having a biocontrol agent on knotweed, this would be, it would be great if they would go and take a look and make a public comment supporting this. So, and I have the websites later on at the end of the talk. So in terms of the future of biocontrol work on knotweeds, so we will continue to release the Kyushu and Hokkaido biotypes. Hopefully the Murakami biotype gets permitted, and we may even be able to release that this summer. And then the larger group of knotweed biocontrol workers are looking at going and doing even further foreign exploration for other potential agents and doing continued testing for other possibilities. So we're not yet at the double rainbow stage of biocontrol of knotweeds, but we're getting places with it, and the future looks hopeful. So thank you to all of those that have helped make the biocontrol program a success and have worked on this project as well, particularly all of our collaborators in Oregon who have helped with providing us with agents, and for our county collaborators as well. And I just want to thank you for your attention and for staying awake through this all. And if you have any questions, I guess we're taking them in the discussion portion of this. So, but if you need further information, you can scan these QR codes. So there's the Biological Control Program website if you need to contact us for any reason. There's also a booklet on biological control of knotweeds that you can download the PDF of from this middle one. And then if you do want to go make a comment on the release permit for the Murakami biotype, that's this third QR code over here. So thank you very much.
Chris, thank you. That was fascinating. I appreciate all the hard work, careful work that you're doing there. And it sounds like there might be even better things on the horizon.
We hope.
So we have another poll, poll 6, and then we'll take a 5-minute break and come back for a brief panel discussion and any Q&A that came up. So yeah, let's just look at this poll and then also enjoy like a 5-minute break. Come back at 12:40 for the panel Q&A. But you asked the All right, we're, oops. Hey, everyone, welcome back. Thank you. We're going to answer some questions from our guests and also take a little time for panelists to dig deeper on points that they made or talk about important points that are sort of ancillary to this topic. So without further ado, Stephen, is there a question or questions that came up from the audience?
I'm gonna punt that to Anna because she has the copies.
Yeah.
Okay, great. Yeah.
So everybody should be able to see in the answered question portion of the Q&A. But Stephanie Gauntz had one as far as how to navigate the conversation to the public around the need for chemical treatment for the species while Marin County has implemented no pesticide ordinances. I just wanted to clarify first, we have an IPM ordinance at county level, and that is something that, applies to county-owned properties and properties managed by the county of Marin. There's lists of pesticides and herbicides that can be used on those properties that are other than conventional pesticides. But there is still also a process to allow pesticides to be those conventional pesticides to be used for a temporary time period. So in the case of the properties that we're working on, because they're private properties, that IPM ordinance wouldn't necessarily be pertinent, but at the same time, the question around herbicide is a huge one with the public. It's one I think that I was most hesitant to, initiate as the Japanese knotweed outreach coordinator when I first started the position. But I think one thing that, there are a couple of things that I've tried to stress is that our goal is eradication, and we're using very, very limited amounts of herbicide to target these very, otherwise hard to treat with, digging, mowing, targeting, or any other sort of treatment, cultural, mechanical treatment methods. With the idea that, we're seeing decreases in the amounts of herbicide used, with the eventual goal that we won't be using. So I think, having that sort of the messaging has been something that has been important to stress. And I also sometimes with the public bring up the sort of the antibiotic example where it's like, yeah, I don't want to be on a normal basis taking antibiotics, but at the same time, if I have a bacterial infection that my body can't handle, and the same way that an ecological system can't handle this phase of plant coming into it, it's really important to use some of those tools and have a really targeted approach. So that's sort of how I approach that conversation. I don't know if anybody else wants to chime in as far as other ways that they approach that.
Anna, I guess I would just add that my approach with those conversations is a take the time approach. How, what is it? Hearing the homeowners or the person's concern. For us, it might be a member of the public, trying to make sure that that we understand what they're actually concerned about, and to share all of the mitigations that we do take to instill confidence in the high degree of professionalism that we put into this work. I've seen that show some effectiveness, and emphasizing our commitment to early detection, rapid response, and relating something like Japanese knotweed to a wider problem that they might understand. In Marin, I often use the example of French broom because a lot of folks in Marin are familiar with that. And sharing that our work in the early detection realm is really trying to prevent a situation like the next French broom, which may have different impacts than French broom. In this case, it might impact the fish on the creek. So talking about what we're trying to protect and that high degree of professionalism that we put into the task.
That's great. Very good. Thank you. Another question?
I just wanted to make a mention too,
Sure.
that in dealing with, again, just sort of a broader, summary of some of the issues I've seen with dealing with private property owners when the county wants to come on the property. 90% of the concern for the people that I've dealt with is more the county discovering illegal building construction, discovering that they're operating an Airbnb and they shouldn't be because that's against the county ordinance, extending their fence into a public right of way that they don't actually own. Those tend to be where the people get really, really concerned. And ironically, herbicide is often not the top concern. So,
Mark, I think that's very wise. There's a new grant out in my area for fuels reduction and also home hardening assessments. And my first question to the county administrators for that program was, are you looking for other violations? And I'd like to see it in writing that you're not. And I don't think I have any, but I'm a newer homeowner and violations can be very expensive to remediate. So just some practical concerns on the homeowner side.
yep.
Mark, talking about people's fears of when they are concerned about these herbicides being used, and they just imagine it's, tanker trucks. Well, can you speak about how little herbicide is actually required, the concentrations?
Yeah, I mean, we generally use, and maybe I'll talk a little bit about the stem injection comment as well, because it'll piggyback well. But as I described in my presentation, the foliar mechanism for uptake is really ideal for us because we can actually use the lowest percentage of herbicide to make that coverage. So if we have good foliar canopy, that's like the optimum environment to spray. And even though it sounds counterintuitive to want to spray more volume, it's actually a really, really low volume of actual active ingredient of pesticide, around 1 to 1.5% in solution, which means that there's very little impact. Like even if some would drift away to a neighboring plant or something, it's at such a low percentage that it does very little harm, and yet a lot actually gets into the plant. Now that is versus what someone did mention, stem injection, which stem injection, 15, 20 years ago or something way back, there was a company called, I think, JK International. They came out with a custom engineered device for, I think JK stands for Japanese knotweed, stem injecting knotweed. I remember there was, if you bought 50 gallons of Roundup at the time, you got a free one because they were really trying to promote it for certain plants. But when we did the research on it, and I was actually an early tester of that, the stem injection used 25 to 30 times more active ingredient in a concentrated format, like an undiluted concentrate straight from the jug, to get the same level of impact to the actual plants. So then we go back to IPM and we look at it. Is that really what we want to do? Do we really want to increase our herbicide use rates 25 to 30%? I mean, it seems like a good idea to inject it inside the plant instead of, covering the outside leaf canopy. But the reality is, for whatever reason, it's not a very, that plant structure, the stem of knotweed, is not a very good conductor into the phloem for whatever reason. Like in some instances, we know woody plants, we can find the phloem pretty easy by getting just beneath the bark. We can find the cambium. That's pretty much where the phloem is. And so for certain woody plants, we can really target that really, really well and get a phloem herbicide into the phloem where we want to get it. But Japanese, and I'm not an expert at Japanese knotweed, structural, plant structures by any means, but it is a hollow stem but inside that hollow stem is just a cavity. It's not like a giant tube that goes down to the roots. It's a giant tube that ends at a node somewhere. So likely a bunch of herbicide is going inside the stem and setting inside the stem and not really getting into the phloem tissue where it needs to go. So.
Great, thank you, Mark. We have another question, Rachel.
Yeah, about the bird nests. First, I would also toss in about the stem injections, that a lot of the plants that we're finding at this point, I think that tool would go straight through the stem. They're very small, so there isn't much cane. But we have a question here from Eric regarding whether we've observed any bird nests in or under knotweed or other breeding activity of birds. This is fairly common in the northern states and southern Canada, but he doesn't have any records from California and is writing a paper on this subject. Eric, I think you and I have exchanged emails in the past on this topic. And through 2022, I still have not seen any bird nests in knotweed. I am familiar with a patch out here in Sonoma County as well. I think our stands are relatively smaller and more discreet than some of those larger stands of knotweed that you might see in those wetter climates. That's my guess. We see a lot of bird nests in our surveys. I showed you some pictures. So it's something that we're certainly on the lookout for. And as somebody who looks very closely at these plants, does the survey and the treatment, I feel confident that we haven't observed that on the public lands in Marin. We did at one point have a patch that had, I think our largest patch had 427 stems. That was back in 2019. And even that one, the plants were not like, they were, maybe like shoulder height. They weren't as massive as some of the ones that you see, and it wasn't particularly, they were dense relative to what we see, but I've seen Japanese knotweed in the United Kingdom, and it's like a different, it's the same plant, but it has a different density to it. I don't know if anyone else has any contrary experience where they have actually seen nests in knotweed.
I haven't either, Rachel, and especially at the beginning, I take a lot of pictures and try to get a lot of good photos, and so from the other side and kind of getting into some of the stands, but I've even kind of been in the midst of some of our larger stands here, which might extend 50 feet by 10 feet max. That's our large stand. I haven't seen this, but I tend to associate it a little bit more with like blackberry too. That is that really dense thicket.
That's great. It's a sensitive and important question, but it's interesting that we are finding birds' nests, but not necessarily directly on or amongst them. And we'll continue to keep an eye out for that moving forward in case birds adapt over time to make use of it in the environment.
My sense, Lorenzo, is that in Marin, where it's under management, the conditions for nesting will continue to decrease. So unless we walked away and allowed those plants to revive into larger stands, the plants that we're managing now are so small and dispersed that I can't think of a site on the 8 miles that we manage that could provide any sort of nesting structure at this point.
Thanks, Rachel. Are there any other?
There's one more.
Yeah.
Two more questions.
Oh, yeah.
Oh, great.
Okay.
So you should be able to see them in the open question. One of them was, were there any other concerning invasives found during surveys besides Melfurta, and will the Melfurta be treated in the future? Rachel, probably the best.
Yeah, so we treat the Malfurata on the surveys. Almost always there might be a situation where we were running up against the end of the day and we didn't get it. We actually take those records back out in the field with us along with the previous knotweed records, and we do look for them. even though it's not our primary focus, we cannot help ourselves. So we're manually removing those. Sometimes they're in fruit at that time of year, so we're removing the fruit as we go. Other invasives that we've seen of one that has and it's been shared, the agencies are aware of it, pokeweed, Phytolacca, probably Americana, has been, this is another bird dispersed little, I don't know if it's really a berry, from the eastern United States. That surprisingly, that's planted as an ornamental, and I think that the Malferata or Hypericum grandifolium is also come to us as an ornamental. And we've seen some yellow flag iris, also an ornamental. Haven't done anything with the yellow flag iris or the pokeweed, which is the pokeweed, the Phytolacca. And then one of our partners from Marin Water saw Ajuga repens, which is a weed up north in some of the wetter areas. I can't recall the common name right now. I think they removed it on that winter habitat site where they saw it. We haven't been, that begins to become too many species for us to look for at that point. We've grabbed some data on the pokeweed. We've shared that information with the agencies to fold into their invasive plant management prioritization for their invasive plant programs.
Super. And maybe this is when you want to talk about, Anna, trying to communicate with the public. Do you think media or direct communication is more effective?
Yeah, so I think, you know, at the end of the day, direct communication is always something that you can have those conversations, and as Rachel mentioned, you know, kind of better understand where people are coming from, maybe in terms of any hesitancy in terms of either land access or treatment. I think, you know, in terms of some of the broader awareness of Japanese knotweed, though, you know, as Rachel mentioned, like French broom, people know about French broom at this point. You know, you're taught as a fourth grader, you may experience, you know, going out and pulling it as part of like a schooling experience. And there isn't that broader knowledge around Japanese knotweed still, as there is in other instances, like, you know, like I mentioned, Northeast or other places where I've personally lived. And so I think the media, you know, you have that ability to reach the broader public, but at the end of the day, in terms of getting our work done on the ground, that direct, you know, door to door or phone or email conversations, often, you know, in person, even as what I've found is the most successful. And, you know, COVID obviously for a while has hindered that. So we were very lucky in that the primary bulk of our door-to-door outreach was in 2019. You know, we were able to continue, and I know it was a challenge for the MCAT partners to continue, you know, the survey and treatment work throughout COVID. But it was something that we were able to do. Well, I think, you know, if we hadn't been able to do some of that door-to-door outreach, we would have seen a little bit less.
Thank you. So if there's any other issues or topics that we would like to bring up before the final poll. Panelists, I welcome you to make a final point.
Just to tag team onto Anna's answer there, you know, I think that the mixing of the media and direct communication can be helpful. Having the message amplified maybe before those surveys, I know that letters were sent, just hearing about it in the community from some other source than that first contact, I think can sort of boost credibility. You know, I heard it on the radio, this lady that showed up at my door is a real thing.
Yeah, there's the nimbleness of in person, but then sort of this validation of also making the public statement. Systems.
I will say, you know, it's something that, especially I was doing most of this work for myself the first couple of years, and, you know, transition now to resurvey with people the last year to, but with door knocking, and I don't, know necessarily would be the case if, I were, not a young female, but it is something where I also feel like I come across as non-threatening, in my initial interactions with, homeowners, and, they're more likely to open the door for me probably than maybe somebody else. And obviously official hats and, all of that, making sure that I'm a branded, entity when I first interact with them. But, yeah, I think it's something where people can be very wary these days about someone showing, it's especially in it's a rural area where we're working. And so it's not like you have, a neighborhood setting where people are often coming to your door. So I think being mindful of that and kind of both in the work that I do, being aware of, okay, somebody could be, potentially not happy to see me, just show up on the doorstep with something. Also, it's, my work, I need to be aware of all this doing the work.
Yeah, I just want to say that it's a testament to Anna's many years of hard work building trust, and charisma have really helped this project move forward. And I know it's hard to put this in a government contract, but you really need a person like that, because I have been on other projects where the government representatives have been lacking in those attributes, and doors slam in our face, people won't respond. Worst case scenario, you get to their gate and they answer it with a gun and say, "Get off my property." And that is the other way that this kind of project can go. And those are the A-rated projects that I work on that are unsuccessful, right? So.
But I do think something that was, a selling point often is I could say, hey, I live up the road, literally. I'm from this community. I have some of the same concerns you do. I hear you, and I think, the quote that I ended up with, it's, we're trying to make the best choices that we can, given, the information that we have available. And we don't know what the future knotweed will look like. We can't predict whether we're going to be able to, completely eradicate it in 5 years. We don't have that foresight or foreknowledge. But, we're able to say, hey, this is what it's done in other environments. We know the characteristics of the plant, this is what it was good at doing. And we have to also not be afraid to act and do something, even though, I think there is sort of, there's a lot of uncertainty around weed management work of both, can we successfully kill this weed in certain instances, and can we continue to sustain momentum that's necessary for these larger lands of weeds.
All right, great. Thank you very much. That's going to conclude our panel Q&A. I would like to invite any individual landowner, land manager, agency, personnel, scientist, or park employee to reach out to us if you have any more questions or if you any advice. We want to be able to help other people do this in the future. And we're very proud of what we did here. There's this last poll. And after that, the people who were taking the exam for CPU is pretty stable. Conclusion. I would just like to thank the panelists and guests, as well as Stephen Swain, Anna Dirksey, and Bonnie Nielsen for webinar support today. David Lewis and UC Cooperative Extension Office staff, also the UCANR, and especially the partners of the Marin Knotweed Actions. Now, for the exam, it is crucial to include your name and license number. So questions 1 and 2 ask for that. You need a 70% pass. Questions 1 and 2 do not count towards that. And you may need to email me after the exam with your name and license number if you have any problems, issues, with doubts. So without further ado, we'll end this final poll and we'll start the exam for everyone who wants to take it. Thank you all again for attending and all your participation. Questions. I just want to check.
Okay.
Just want to check in and make sure people are able to take the exam. No one is obfuscated to take the exam. Check.
Lorenzo, I don't think the panelists can because it's set up like we can't access that. We can only see the results.
Okay, and I'm pretty sure that when you're an educator or presenter in one of these, get credit. Like participants. Stephen and I will chase down those details.
I'll send you my answers in a separate email just so you have it.
Excellent, thank you.